What does simultaneous mean? And boy, the special relativist, especially Einstein, he got tied up in knots trying to figure out simultaneity. And here it is. This is the definition from the Wikipedia. In mathematical physics, I put the mathematical in there, right, because that's not physics. The relativity of simultaneity is the concept that distance simultaneity, whether two spatially separated events occur at the same time, is not absolute. Okay, so they're saying two events do not necessarily happen at the same time, but depends on the observer's reference frame. Okay, that's when they happened. When each observer, according to his reference frame, says it happened. Okay? This became a central idea in the special theory of relativity. So keep in mind, special relativity is based on this nonsense that it depends on the reference frame of the observer. So there is no simultaneous occurrence. Like I say, if you shake hands with someone, that did not happen at the same time. For you, it happened this time. For him, it happened at another time because you were in a different frame of reference. Kind of. That's more or less like it is. People say, well, Bill, you're making a joke out of these people, but that's what it amounts to. Okay, it amounts to saying that, if a star exploded in a given frame of the universal movie, and everybody sees it at different times, well, the star exploded in that frame of the universal movie. What people perceive, what they measure, what they think happened is different. Okay, and so again, special relativity has to do a lot with observers, and in science we kill the witness. There are no witnesses. There are no observers in science. We just need to explain what happened, and for that you need to establish the objects and the definitions. And that's where special relativity just falls apart completely. According to the special theory of relativity, it is impossible to say in an absolute sense that two distinct events occur at the same time if those events are separated in space. Absolute poppycock. Absolute poppycock. They say that there's no way of telling. It's impossible to say whether two events happen at the same time or in the same frame of the universal movie, essentially. If one reference frame assigns precisely the same time to two events that are at different points in space, a reference frame that is moving relative to the first will generally assign different times to the two events. In other words, what they're saying is, if you're moving and I'm moving, we're both moving with respect to, a supernova, and you're in one planet, I'm in another, we're going to see different things. So I'm going to assign a different time according to my clock and my calendar than you and yours. Well, I don't care about that. That's measurement. The question is, did the supernova happen in a given frame of the universal movie? And these people are trying to tell you that the event did not happen in a single frame, that according to your location, your distance from the event, this event happened in this frame of the universal movie. And in the other fellow's version, it happened in a different frame of the universal movie. That is absolute poppycock, nonsense of Einstein and special relativity. That has no place in science. Absolute nonsense. Let's show this in images so that people are convinced of the argument, so they can use it against any special relativists out there. Okay, let's make sure we smirk and laugh at them and if you can't beat them, ridicule them. That's my take on that, okay? So here it is. Here's two supernovas happening in a given frame of the universal movie. It happened in frame 632. You can see two supernovas. They happen in that frame. That's when it started, when the explosion was about to start. They both happen exactly on that same frame, okay? And they keep growing from there on. But we have two observers, one very close to the two events and the other one farther away. Okay, and so what happens in the next frame of the film? Well, we got to look at this frame by frame, okay? So here we have the first frame, right? And nothing happened. And here in the second frame, we have the supernova happening, but neither of the two observers has seen any of these two events happen, okay? But the two events happen in a given frame of the universal movie, because every atom in the universe is at a given location with respect to all others. There's distance between any two atoms. There's only one frame in the universal movie. There are not two frames or 10 frames. There's no movie. Father Universe does not recognize a movie or motion or time, right? So these two events, this thing that's about to happen, this explosion, happened just by sheer coincidence in the same frame of the movie. Let's not talk about time or motion. Let's say it's in the same frame of the universal movie, and you can see the two observers are in different reference frames, right? In different locations. Okay, so what happens next? Well, the light from the event starts exploding, right? And it's probably going to arrive at the first observer far faster than it arrives at the second observer, okay? Because the second observer is simply too far away from the event, okay? So what happens next? Well, in the next frame, you can see what's happening. The light now reaches one of the events of, we'll call it supernova number 1, the one on the top, reaches the first observer, okay? But as you can see, the light from the second supernova, right, we'll call it the second one, the one on the bottom, is a little farther away, so it hasn't reached his eyes yet. Only the first one has. And neither of those two events has reached the second observer, okay, because he's just too far away from the two events. Okay, so what happens next? Well, now we have frame number 5 here, 635. The observer, first observer, he sees now for the first time the event of the second supernova. He's already seen the first one. And the second observer, he hasn't seen either one of them. He's still waiting for the light to come to him from either event. And now, for the first time, observer number 2 sees the light from the first event, but he doesn't see the light from the second event. So you can see the progression. What we're saying is the two supernovas occurred exactly in the same frame. The light reaching each observer and what they measure and how fast they're moving and all this stuff has no bearing on the simultaneity, which is a single frame of the universal movie. That's what simultaneity is in science. We have to put it in the right context. What is versus what people measure. You know, what people measure is irrelevant in science. We don't care about measurement. You know, we care about what is reality. And these people are out of touch with reality because they come up with all this nonsense based on their measurements. They say, well, I measure this. And the other guy said, well, I measure that. And so those two measurements don't coincide, and so they reach different conclusions, and they had to create the equations to justify each one of the opinions of when the event happened. So they concluded, instead of saying that the two relativists are irrational, they said, no, the event did not happen at the same time. For me, it happened this time, the other one happened that time. It's like you go to a jury, a trial, you know, and the guy is both guilty and innocent. The defendant, he's both guilty and innocent. For one juror or half of the jurors, he's guilty. For the other half, he's innocent. Okay, so should we flip a coin? Well, instead of giving him 10 years, we'll give him 5-year sentence because it's half the jury. Okay, so that's the way it works in special relativity. They all vote and they say, well, we'll use the equations to justify that we're all right. He's right and so am I. It's all relative, right?